Hello everyone, here is a question based on reductive ozonolysis and IUPAC nomenclature. A and B are undergoing reductive ozonolysis. A is giving two different aldehydes and B is giving an aldehyde, but it has a keto group at 5th position. So let's write down the structure of these three different products. Then we can come to the conclusion which are the starting materials. So ethane 1,2 dicarbaldehyde. So this means CH2 CH2 and then C double bond OH on both sides. So this is ethane 1,2 dicarbaldehyde. And then glyoxal, that is the smallest dialdehyde. So two aldehyde functional groups joined together. That is glyoxal, or otherwise called oxaldehyde. Oxaldehyde is the preferred IUPAC name. And then 5 oxohexanal, that means 6 carbon atoms are there. So let's write it this way in bond line notation: 1, 2, 3, 4, 5, 6. At 5 position we have a keto group, and then 1 position we have aldehyde. So 1, 2, 3, 4, 5, 6. This is 5 oxohexanal. Now, if the starting material for B is cyclopentene, is it possible to get this product? No. Why? Because if cyclopentene is the starting material for B, what we will get? We will get aldehydes at both ends, because this has a hydrogen here and a hydrogen here. So that means what we will get is this product: 1, 2, 3, and then so 1, 2, 3, 4, 5. So there also one aldehyde. So this is the product we will get if cyclopentene is the starting material for B. So that means wherever is cyclopentene is given, those answers are definitely wrong, because if the double bond has an hydrogen, then we will definitely get aldehyde. If the double bond has no hydrogen, then only we can get a keto functional group, isn't it? On the contrary, when the starting material for B is 1-methyl cyclopent 1-ene, that is given at 2 places, then the product will be 5-oxohexanal. So this is the structure of 1-methyl cyclopentene. When this molecule undergoes ozonolysis, then we would get the ozonoid first. Here we have no hydrogen, here we have hydrogen, therefore at this place we will get the ketone, at this place we will get the aldehyde. So let's mark it here: 1, 2, 3, 4, 5, 6. So we would get the aldehyde on one end, hydrogen. This is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and then sixth. At 5th position we have the keto group. So this is 5-oxohexanal, but in both C and D it is mentioned as 1-methyl cyclopent 1-ene, and therefore we have to think about A, whether A is this one or this one. If the starting material for A is 1-methyl cyclohex 1,4 diene, is it possible to get ethane 1,2 dicarbaldehyde and glyoxal? The answer is no. The reason is, in 1-methyl cyclohex 1,4 diene, let's write down the structure of that: 1-methyl 1,4 diene. We have 7 carbon atoms in total here, isn't it? If we include this carbon also, then we have 7 carbon atoms. But then in the products, do we have 7 carbon atoms for A? We don't have. The products of A should have only 6 carbon atoms, isn't it? 1, 2, 3, 4, 5, 6. So this is another way of checking. One way of checking is, if the double bond has a hydrogen, we will get aldehyde. If the double bond has no hydrogen, then we will get ketone. The other way of checking is total number of carbons. So we have 7 carbon atoms here, isn't it? I'm just writing in terms of carbon atoms. This is not for IUPAC nomenclature. So total number of carbon atoms is 7. So here we will get ketone, here we will get aldehyde, here also aldehyde, here also aldehyde. But then the total number of carbon atoms are neither going to decrease nor going to increase in reductive ozonolysis. So we have 7 carbon atoms, but on the products for A, we have only 6 carbon atoms. Therefore, this is definitely not the correct answer. But on the contrary, if cyclohex 1,3 diene undergoes reductive ozonolysis, then we will get these 2 products. So this is the structure of cyclohex 1,3 diene. So if this undergoes ozonolysis, then what will happen? We will get the diozonide because we have 2 double bonds. So how our intermediate will look like? The intermediate will look like this. So that's how our intermediate will look like. Do we have 6 carbon atoms? So 1, 2, 3, 4, 5, 6 we have. And then the reductive ozonolysis happens. And the breakup happens this way. So here we are going to get aldehyde. Everywhere we are going to get aldehyde. So 1, that one, 2, this one, 3, 4. So 1, 2, 3, 4. There 1 aldehyde. Just to avoid confusion, I am writing the hydrogen atoms. So this is our ethane 1,2 dicarbaldehyde. And then the other product is Glyoxal, which is here aldehyde, here also aldehyde. Hydrogen, hydrogen. So therefore the correct answer is option